Hello viewers, you're welcome to edumathhub. In this video, we're talking about set theory for MAT101, MAT101. So let's get right into the video real quick. So this is set theory. So we'll start with the definition of a set. So a set is just a collection of objects, numbers or letters. Okay, collection of objects, numbers or letters. Maybe they share a common characteristic. Okay, so an example of that is the set A equals to 1, 2, 3, 4, 5. So if you have something like set y is equals to maybe 2, 3, 4. So this is a set, just a collection of letters or numbers enclosed in curly braces. This is the curly brace here. Okay, so you have set A equals to 1, 2, 3, 4, 5, which are natural counting numbers, as in 1, 2, 3, 4, 5. Then in this part here, you have set V. Set V is A, E, I, O, U. These are the set of vowels in the English language. These are the set of vowels. So they have a common characteristic. Okay, so you enclose them in a curly brace. Okay, so each member of a set is called an element. An element. So this A is an element, E is an element, I is an element, and so on. Okay, they are the members of the set, so they are called elements. Okay, then the members of a set are enclosed in curly braces or brackets. Okay, so when you write V equals to, open your curly bracket, A, E, I, O, U. Okay, this is your curly bracket here. The members of the set must be inside that bracket. Okay, now the names of a set are represented with capital letters. So when you're representing set, you don't represent set like this, set A, small letter, no. You start with a capital letter. Most of the time, that's the convention for, as generally in mathematics. So V equals to 2, 3, 1. Okay, Y equals to 4, 2, 3, and so on. Use capital letter to start the name of the set. Okay, now that's just the introduction. So we're going to start with some basic examples. Let's talk about the cardinality of a set. The cardinality of a set. The cardinality of a set means the number of elements that are in that particular set. So, for example, we have set A is equals to 1, 2, 3. The number of elements that are in this set is just 1, 2, 3. So, to write this answer, you write it like this. You write N A, which means the number of elements in set A. Then the counting that you just did, that's 3. There are 3 elements here, 1, 2, and 3. Okay, that's just cardinality. It's very simple. The number of elements that are in a particular set. But you have to be very careful. If there's any repetition in that set, or any element that is repeating, you won't count it twice. You count it once. For example, you have set A is equals to 1, 2, 1, 3, 5. So if they ask you the number of elements here, you just write N A. So you have 1 here, 2 here. You won't count this one again because you've already counted it here. Okay, this is 3 and this is 4. So the number of elements will be 4. Okay, hope you understand. Then you have some exercises here. You have to find the cardinality of the following sets. The cardinality of the following sets. So for the first one, you have set A equals B, C, T, F, G, X. So let's count. So you also have 1, 2, 3, 4, 5, 6. Nothing is repeating here. There's no repetitions. So we just write N, A is equals to 6. That's the answer of this one. Then for this second one here, you're told that B is equals to A, B, E, F, G, K. Take note of something. This bracket here means that this guy is single. It's a single element, though they are combined together. But this bracket inside shows that they are combined as one. Okay, so if you count it, it's just 3 elements that are here. 1, 2, 3. Okay, don't count it like A, 1, 2, 3, 4. No, it's wrong like that. So the number of elements in this set B is just 3. So for this next case, this is set C. Set C. We are told that set C is 2, 3, 5. So don't count this one again. You've already counted it already because this is 3 here. Then you have 6, 9. So number of elements in set C will be 5. 1, 2, 3, 4, 5. Okay. Then for the last one is actually an empty set, though I forgot to write it. So let me just put it there. Empty set. So this symbol here is used to denote an empty set. That's a set that does not have any elements. So for example, if I ask you now, name lecturers in university with 2 heads. There's no lecturer in university with 2 heads. So it's impossible to see any element like that. So that's an empty set. A set that does not have any element. Set of goats that can fly is impossible. So it's an empty set. So it does not have any element. So for this answer here, it will be NT is equals to 0. There's no element there. So that's going to be NT equals to 0. Okay, so let's move on to the next part, which is subsets of a set and then supersets. I'm going to use these 3 examples to explain what is subsets and supersets. So when you hear subsets, sub means under or part of. Okay, so subset is just another set that contains the elements of another set, maybe all the elements of another set or part of the elements of the other set. So if you have a set A like this now, so A has 1, 2, 3, 4, 5, 6, 7. Now from set B is now 3, 6, 7. You see that set B contains 3 elements from set A. Set B has 3, it has 6, and it has 7. So that means this B here has been taken out from set A. Okay, B was brought out from set A. You understand? So that means you can write it like this. B, you can say B is a subset of set A. It means that B, you can remember it like this. B is a child of set A because B was taken out from set A. So you can say B is the child of set A. Okay, B was taken out from set A. Also, you can see that B is just part of the elements of set A, just 3, 6, 7. But you can also form another set that will contain all the elements of set A. This set C, for example, contains 1 to 7. Okay, so C is also a subset of set A, but it has a different name. C is also a subset of set A, but you call this C, you call it whole set because it contains all the elements of set A. Okay, why this B, you call it proper set because it does not contain all the elements of set A. So that's about subset. It's very, very simple. Now for supersets, since I said B is the child of A, that means B was taken out from set A. If you want to start with A on this side, you write it like this. You reverse this like this, then you write B here. This symbol here stands for superset. Superset. So it means that A is the father of B. Okay, so A is the father of B, but B is the child of A. Okay, so that's the meaning. This one here means that A here, this B here was taken out from set A. So A is the father of set A, B is the child of set A. So that's the basic example for subset and superset. So for this next question, we have to find the subset and superset of the following sets. Okay, subset and superset of the following sets. So they give you set I, M, N, and Q. You have to find which ones are subsets, which ones are supersets of which other one. So let's start like this. You can see, let's start with set M, for example now. Set M. Set M is 4, 10. Okay, and I also contains 4, 10. Q also contains 4, 4 and 10. So that means M is a child of both I and Q. So you can write it like this. You can say M is a child, that means a subset of I. M is also a subset of Q. Since this is true, then that means I is the father of M. I is the father of M. Q is the father of M. Okay, let's try another one. N contains 6 and 8. Set I also contains 6 and 8. Set Q also contains 6 and 8. So this means that N is the child of I, N is the child of Q. This means that I is the father of N, Q is the father of N. Okay, if you even check, there's also one more that you can also pick. If you look at set I, for example, set I contains 2, 4, 6, 8, 10, which can also be found in set Q, 2, 4, 6, 8, 10. So that means I is also a child of Q. Okay, so you can say I is a child of Q, which means that Q is the father of I. So that's the answer to that question. So there's a formula that can be used to find the number of subsets of a set. Okay, the formula is 2 raised to power n. Okay, these are the number of subsets of a set. N is the number of elements that that set has. So if you have a set like A equals to 1, 2, 3, and you are told to form the subsets of that particular set, the number of subsets that it's going to have is equals to, the number of subsets will be 2 raised to power n. But what is n here? N here means the number of elements that are in the set. So put it there, that will give you 2 raised to power 3, which will be 8. That means this set here, you have 8 children, okay, or 8 babies out of it. Now you might be told to write those babies or to write the subsets. So you write it like this. So you have A, 1, 2, 3. So the first one, or the first subset, first of all write empty set. For the second one, write the whole set, that is 1, 2, 3. 1, 2, 3. For the third one, you pick the set 1, 1. 1. This is 4. You pick 2. 5. You pick 3. You know you have 1, 2, 3 in the set. So you pick them 1, 1. The next one, you pick them 2, 2. So you can pick 1, 2. 1, 2. Then you can pick 1, 3. 1, 3. Then the last one, you just pick 2 and 3. 2, 3. So these are the 8 subsets of the set A, if it has 3 elements. So don't forget the formula. The formula is always 2 raised to power n, where n is the number of elements in the set. If the set has 5 elements, for example, the number of subsets will be 2 raised to power 5, which will be 32. So I hope you have gained something from watching this short video talking about the definition of a set, how to represent a set, the number of elements in a set, cardinality, and subsets and supersets. So I'm going to post the next aspect, which is operation on sets, talking about union and intersection. So try the exercise on the screen right now. Try it and post your answer in the comment section. So I'll see you guys in the next one. Thank you for watching this video. Kindly share this video with your friends so they can gain 1 or 2 things. And if you have not subscribed, please subscribe, okay? Thank you for watching. Take care. I love you guys. Goodbye.